Okay, guys. In last session, we discussed about data source view completely, data sources and data source views of SSAS. So in today's session, we are going to discuss about a couple of interesting topics. These are not part of development. It's not an SSAS development related task, but this is entirely related to design part of SSAS. So whenever you are working on any SSAS project, two things will be there. One is design and another one is development. So if you see here, the development, it's easy to do always. The design is the toughest job. And people expect, the interviewer expects some experience on designing of SSAS cubes also. Okay. Under this design, we are going to cover a couple of topics. The first one is schemas. The next one is what is cube, and the third one is master and transaction tables, master and transactions, and the fourth one is dimensions and facts. So we're going to discuss about all these four concepts in today's session. It will be very interesting. So be active, and this is very important concepts also. Okay, let's start with schemas. This is the must and should interview question. If you go and give any an interview to any company, the first and foremost question people ask you is what database schema you used in your last SSAS project. So what is meant by schema here? Okay, schema is nothing but how the tables are arranged, how the tables are organized. There are two types of tables. As we all know, one is master table and another one is transaction table. Okay. Now let's see the schema part. Schema will tell you how your tables are arranged, how your master tables and the transaction tables are arranged. The same master tables in SSAS concepts, we call it as dimension tables. In SSAS, we call it as dimensions. And transactions, we call it as facts. Remember, this is not always. I can say 90% of the master tables are called as dimension tables and 90% of the transaction tables are called as fact tables in our schema. Before going further, first let's start with what is master table and what is transaction table. We already discussed about these two concepts in the institute, and even in online sessions we discussed about these concepts. What is master table and what is transaction table? Master table is the one which will have the data, master data, the information about the business or the information about the entity. Let's say if you take the bank as an example, banking site. Let me take an Excel here. Oops, I don't have Excel. Pathetic. Okay. Then in that case, let me take the pen. So let's say this is my table. Very poor in drawing. Try to adjust with this. And if this table is having all the details about the customers like customer ID, customer name, customer mobile, customer phone number, customer phaser, customer fax number, and customer PAN card number. So if I have some information which will explain about the entity or any business, or I can say this is a textual information. This is not a metric. This is a textual information. So in other words, I can call it as the table which is having primary key, for which we will define primary keys. So the master tables are nothing but which will have the master information. Let me tell you a couple of examples so that you can apply and check the same. Okay. First example is customer table. Customer table is a master table. Why? Because you will have customers, right? Customers information, and no customer information will be repeated. you will have unique customer information like Rupesh customer details will be present only in one row. Okay, and to explain better about this, I feel this is the time we have to go for SQL Server Management Studio, and let me design a master table and a transaction table. Let me go to some, I'll create one database. I'll name it as testing. So I'll select this and let me create a table where I'm gonna capture the information about let's say Rupesh customer. So for that I'm creating a table, create table customers. I'm giving customer ID, integer, name, varchar of let's say 50, and city, varchar of again 50, state, varchar of 30, country, varchar of 20. Let's say like that you have some couple of a couple of columns. So if you see this table, I will have customer name Rupesh only once, and this Rupesh will have one customer ID, unique ID. It will not be given to any other guy. That will be unique. So, and location name only once, and he has its own unique ID. Unique ID is nothing but your bank account number. For Rupesh customer, I'll have one bank account number. This account number will not be given to any other guy. So where you will have the primary key data, where you will have the textual information, or where you have the master data, we call these tables as master tables. So the main how you can identify a master table is the first thing, it will have a primary key defined here, primary key column. And next thing is there will be no duplicate records. At least one column will be unique in this particular table. Let's say if I define as a primary key, for sure I'm not going to get any duplicate records into this particular column. I cannot insert duplicate records, right? If I define a primary key on a table, that means this table is a master table where I'm going to maintain some data. It's a master entity or business related information. So the difference between master table and the transaction table is, transaction table is the one which is having all the transactions. Okay, let me create a table, transactions. Here I'll have transaction ID, let's say integer, and next which customer has made this transaction. To find out that, I will have customer ID and amount transferred, amount withdraw. Let's say this is integer, and amount deposited, this is again integer. So if you see here, the same customer ID will be repeated again and again. For example, if I go to bank today and deposited some 10,000, there will be one record in this transaction table saying that Rupesh customer name Rupesh with name Rupesh has deposited some amount 10,000. Tomorrow if I go and draw 2,000 rupees, then one more record will be inserted for the same customer Rupesh, right? So that is the difference between master tables and the transaction tables. Master tables will not be duplicated, will not it's always unique, and um, the one which is having primary key is called as master tables basically. And here we define foreign key. I don't know how many of you guys still remember the foreign key concepts. Here we'll define foreign key references. What is the table name? Master table name. Customers of, what is the column? Cust ID. So In short, the primary key table is called as master table, and the foreign key table, the table which is having foreign key relationship, is called as a transaction table. Let me show a couple of examples for this. Okay, I can show you a couple of examples for the same. What is a master table and what is a transaction table? For that, let me open the data source view which we created in last session. Okay, fine. Here, if you see dim sales territory, this is having a primary key column, right? And this one is having a key column, this one is having a key column, this one is having key column, and this one is having key column. And if you see all the tables, this is trying to tell you some textual information, like here currency name, here if you see country name, here if you see year name, quarter name, month name, and so on. Here if you see customer name, here if you see promotion type name, promotion name. So all these tables, the tables that are surrounded to the fact internet sales table, are having some textual information. And this is having primary key, and you can see the data will not be duplicated. Why? Because primary key is defined here. So here if you see the fact internet sales table, here you will not have any textual information. You will have all the keys from the parent table or master table, and all the keys are foreign key referred. This product key is foreign key referred to, it is not foreign key referred. Let's say this customer key is foreign key referred to dim customer. If you have any questions, you can, if you have any doubts, you can see here. The customer key is foreign key referred to dim customer table customer key. So this is your foreign key table, and these are your primary key tables. So what will be your master tables here? All the 5 tables are master tables, whereas this one is transaction table. So now let me tell you the easiest way to identify the foreign key tables are transaction tables, and primary key tables are master tables. And let me tell you a couple of other differences. Primary key tables will, master tables will not have duplicate data. There will be at least one column, okay, with unique values to identify the records. Transaction tables may or may not have unique records. It may have unique records, may not have unique records. It is not mandatory that it should have unique records. Okay, so there is also major difference between master tables and transaction tables. And another difference between master and transaction tables is master tables always will have textual information like name, city, state, country. Okay, but transactions, if you see, always it will have metrics. Metrics means the one which is used to measure a value. For example, what is the metrics for the student? His marks is the metrics. What is the metrics for the telecommunication guys? The number of calls the guy is making, the customer is making, is the metrics. What is the metrics for the bank guys? The deposits, the transactions. How many transactions he is doing per day is the metric for them. What is the metrics for what's that business? Courier system, FedEx, or take an example of FedEx. The metrics is the number of couriers they are getting. So always the metrics means it will have some integer or floating values which is used to analyze your business. If you want to say that a particular bank is performing well, it always depends on the number of customers and how many transactions they are making. If you want to say if a courier system is doing well, that means how many packages they are getting per day. In the same way, if you want to say a particular retail shop is doing good, that means you have to say how much of sales are happening. So this is metrics. There will be metrics for each and every business. Metrics are nothing but measuring points of the business. Okay. So now you should get an, now the master table is nothing but primary key table most of the cases, and the transaction tables are nothing but the one which is having foreign key table, and also the one which is having metrics information, whereas the textual information or the business related information will be present in the master tables. So this is about master tables and transaction tables. Now let's apply the same for the data warehousing, SSAS concepts. All master tables, we call it as 99% of the master tables are called as dimensions. Okay. Let's say this is your master table. Chances of using this master table as dimension is 99%. And chances of using it as a fact table is 1%. Okay. Now this is your transaction table. Chances of using this transaction table as fact table is 99%. Chances of using this transaction table as dimension table is 1%. Before going to the statistics, let me explain what is dimension and what is fact table. This is very important to know, right? So dimensions and facts are nothing but dimensions is in which angle you want to see the data. You want to analyze your business. And fact table is what metrics is you are going to use to analyze your business. Let me tell you one real thing that no one might have observed is, if you want to know how a person or how a business is performing, you have to ask two questions, not one question. With one question, it is not possible to get the performance of any business. If you want to try, for example, who won the match, right? That is the question you will ask to know whether who won the match. Here, who is one question. Okay. The second question here is status, that is 1. For that, the answer is given by the question, the guy who is asking the question. Which soap, how much sales? The next question, which soap, how much sales? If you want to know which soap is performing well, then you have to know which soap, how much sales, right? In the same way, if you want to know which item is going hot in a particular restaurant, which item orders get more orders, like in Pizza Hut, which pizza got more orders. So for every question, what I'm trying to say here is, for every question, for getting the status or for analyzing the business of anything, you need to ask two questions. Who scored centuries? Who scored is one question. The second question answer you are giving, that is centuries. You are looking for centuries. Centuries is a metric here. Who? The answer for the who is your dimension part. In the same way, who won the match? Match winning is the metric. And who, the answer to the question who is nothing but the dimension. In simple words, dimension is nothing but, if this is your cube, dimension is nothing but all the sides. How you want to see the data. This is the shortest definition I can give for dimension. How you want to see the data is dimensions. What data you want to see, that is fact table. How you want to see the data means, an example, customer wise I want to see the sales, year wise I want to see the sales, month wise I want to see the sales, quarter wise I want to see the sales, geography location wise I want to see the sales. So if you see the first part in all the questions I have given here, the first part, the way I want to see the data is my dimensions. And what data I want to see, the sales I want to see, or the tax amount I want to see, or the profit amount I want to see, or the match winning team I want to see. So that is your fact part. So facts will be always present in your transaction tables, whereas dimensions will be present in your master tables. If you see, if you apply the same example here, territory wise I want to see you can see the sales will be here, sales amount. Quarter wise I want to see the sales amount. Month wise I want to see the sales amount. Year wise I want to see the sales amount. And in the same way, customer wise, I want to see the sales amount. Currency wise, I want to see the sales amount. And promotion wise, I want to see the sales amount. If you see, all the dimensions is the answer to your first question. And the matrix is fact table. So the fact table is nothing but the transaction table in the database concepts, whereas the dimension tables are master tables in your database concepts. So most of the cases you will go in this way. What is that 1%? You will come to know when we discuss about dimensions and facts and when we start creating those objects. Okay. So the key point here is identifying the dimension table, identifying the fact table. If you fail to identify the dimension table and the fact table, then you are not. That means you are not going to design your cube properly. Your SSAS solution will be a crap if you fail to identify it properly. Let me tell you one simple scenario how the requirements will come from your client. Client will not give some pages of document. What they will come and say, they will come to you and say, I want to see the sales year wise. So what you have to do, first you have to find out where the sales is present. This is the table where the sales is present. So I need this table. And where I have year in this table. So I need this table. These two tables are the one I need to meet the requirement that client has given. So here the next thing is identifying which one is master table, or which one is dimension table, or which one is fact table. So how you can identify that? What is the client requirement? He want to see year wise sales amount. So which column, which table is having year, that will be your dimension table, and which table is having your sales amount, which is a metric to analyze the business, that will become your fact table. So in this fashion you can identify the dimension tables and fact tables. So this is how you have to analyze based on the requirements. The requirements will be like this: currency wise I want to see the tax amount. So this will be your dimension table. Why? Because currency wise I want to see the data. And what data I want to see? Tax amount, that's a metric. And remember, fact table always deals with integer or floating values or money data types. Okay. And dimension tables, maximum cases it deals with varchar data, that is string data. So if the client comes and says, I want to see the data, sales amount and the tax amount information, year wise, quarter wise, month wise, and customer wise, and also currency wise, then I have to analyze what are the tables that are required first. I want these four tables to meet the requirement. So from these four tables, what is your dimension and what is your fact? Dimension is nothing but my master tables, which is having the textual information, how we want to see the data. And fact table is the one which is having what data you want to see. So this is how you have to differentiate the master table and the transaction table, alias, I mean in SSAS concepts, the dimension table and the fact tables. With this knowledge, we can jump into the schemas. Schemas are very important to know. You will get so many questions on schemas. What are the different types of schemas available, and so on. You will get so many questions. You can expect some 3 to 4 questions on that. Let's discuss all the questions here, and before going to that, let's start with how many schemas are present. What is schema? Schema is nothing but the representation of your tables. Whatever the tables that you're gonna use in this particular cube development. Okay. Let's say for my cube development, I want these tables 1, 2, 3, 4, 5, 6 tables. So how these tables are linked? That one is nothing but the schema design. So the schema of your SSAS cube data tables is depends on what are all the tables you are having in your data source view and what is the relationship between these. Now let me explain. There are mainly two types of schema. One is star and another one is Snowflake. So I mean there are only two levels of schemas. One is star and one is Snowflake. And people like me, they will create new schemas, like they will feel there is some other hybrid schemas like star flake schema. It is a star from here and flake from here. They made it as a star flake. That is a hybrid of these two. And few people call some as galaxy schemas. Galaxy. All these are junk things that are being added by the guys who are working on SSAS part. So as far as I know, and it's written in the books or wherever you go, you will find only these. The schema types are two, that is star and snowflake. The schemas that will not fall into star are snowflake. Okay. Now let's see the difference between star schema and snowflake schema. Star schema is nothing but a schema where you will have your fact table. Let me take the notepad. Star schema, it looks like this. The fact table in the middle and all the dimension tables are directly related. Let's say this is my dimension, this is my dimension, this is my dimension, this is my dimension. So when the fact table is directly related, what is meant by related here? Related is nothing but here the foreign key reference. If this master table or this dimension table is having direct foreign key relationship with the fact table, here the same case, here the same case, and in all the dimension tables, if there is a foreign key reference, foreign key reference to the fact table, then this kind of schema is called as star schema. I repeat, star schema is nothing but when the fact table is directly related to the dimension tables. All the dimension tables. When the fact table is directly related to all the dimension tables, then it's called as star schema. Let me show you an example. Here, this is my fact table, right? This is my fact. This one is having direct relationship to this dimension. I'm talking about this dimension, this dimension, this dimension, this dimension, and this dimension, right? So this fact table which I'm using in this cube design is having direct relationship to the all the dimension tables. Then this schema is called as star schema. This is the example for star schema. Okay. Why this is called a star schema? They feel that it looks like star. If you draw the star, you can see very close to star, right? So this is why they call it as star schema. If you see here, if you have a dimension table, fact table here and so many dimension tables surrounding it, and everything is directly related, then you can see this looks like a star. That is why they call it as star schema. The 2 points you have to remember here is the fact table and the dimension table should be there, and the fact table should be directly related to all the dimension tables. So then that type of schema is called as star schema. The next type of schema is snowflake schema. Snowflake schema is nothing but not all the dimension tables will be directly related to the fact table. Classic example is, let me draw the picture how it looks. Let's say this is your fact table and remaining are dimensions. I have one more dimension table here, but this is related to this. If I want to join this fact table with this dimension table, what I have to do? I have to join with this and this one with this, because there is no direct relationship. This is not present. No direct relationship. So when the dimension tables are not directly related to the fact table, then that kind of schema is called as snowflake schema. Let me draw an image, draw a picture. If this is your star schema, the snowflake schema looks like somewhat like this. There will be some table. There will be some table, and it is not mandatory that it should be have that extra dimension table should be there for all the dimensions. It's not like that. Now if you see, this is snowflake, and some tables will be independent, no relationship at all. This is called Snowflake schema. The central one is fact and the remaining things are dimensions, and this dimension is directly related, but this is not directly related to the fact, and this is not directly related to the fact. This one is orphan, no relationship at all. This one is orphan, no relationship at all. So this is the differences between star schema and Snowflake schema. Star schema is nothing but the one which will have direct the one in which all the dimension tables are directly related to the fact table, whereas in Snowflake schema there may be indirect relationships to the fact table from the dimension tables. So people, they invented new things, like they were saying there is other schemas like star flake schema, the hybrid schema. When I asked those guys what is this star schema, star flake schema, they replied this. Let's say I have two fact tables. Okay, one is having star schema, like this, and another one is having Snowflake schema. Okay, one is having star and another one is having Snowflake. Then this kind of requirement is called as star flake. So this is a hybrid one created by Indian brains, I guess. Okay, when I asked about what is universe, when there are so many tables which are independent and no relationship at all, then this is called universe schema. So you don't worry about this universe and star flake. This is just nothing bullshit. Okay, you just bother about star schema and Snowflake schema. Star schema is nothing but the one which will have all the dimension tables directly related to the fact table, whereas Snowflake, there will be no direct relationship between all the dimension tables and the fact table. So people ask so many questions from this star and Snowflake. What type of questions you can expect in interviews? Let me tell you a couple of things. First, what is schema? Schema is nothing but the data table representation, how the data tables are related and what are the data tables available. And what are the types of schema? The answer is star schema and Snowflake schema. And the third question is which one is good in performance? The performance wise, obviously star schema is good. Why? You just need to join two tables. One join is enough for to get the dimension and the fact information, right? But here it is not like that. You have to join with this and join with this. You will get so many complex joins. Some relationships will be like this. This fact will be related to this dimension, and from this dimension another dimension, from this dimension another dimension, from this dimension another dimension. Like this it will go for 10 levels. So if I want to get from here to there, what I have to do? I have to join with this, again with this, again with this, and then finally I have to come here. So that is why Snowflake schema, the performance wise it is poor. Okay, that's the question you can expect. Which schema is best in performance? Star schema is best in performance. And the next question they will ask you is what schema you used in last project. Most of the projects take Snowflake schema, and you better say Snowflake schema as answer. Okay, and next thing what you can expect from those guys is when star schema is good in performance, why you are going for Snowflake schema? So the answer for that one is I cannot convert this Snowflake schema. My database design is so complex, so that I cannot. That's why I cannot convert that one to star schema. Star schema means everything should be directly related. My database design is so complex and it can be achieved only with Snowflake schema. That's the reason. So I showed you, right, this part. You can make this part a star. How can you do that? Take one table here and this table, create a named query. You remember the named query concept, I guess. Named query, and join these four tables in that named query and write the query here. Right, that one will become star. This link will be removed and you can use only this table. So you can convert the Snowflake schema to star schema, but it is very complex. Why? Because nowadays the database designs are coming in a complex, very with high complexity. So Snowflake schema, most of the cases you will go for Snowflake schema because of your database design. And performance wise, star schema is always best. If you talk about if you talk about the relationships here, foreign key relationships in the Snowflake schema, if this is your fact table and this is your first dimension and this is your second dimension and this is your third dimension, so how the foreign key relationships will be set? This guy will have foreign key to this table, and this guy will have foreign key to this table, and this guy will have foreign key to this table. So this is how the foreign key relationship will be set, will be present in Snowflake. Whereas in star, this is your fact table and this is your dimension table, only one level foreign key. So that is the difference, right? Here you will have foreign key through some dimension tables. So this is how you can differentiate the star and Snowflake schemas. That is about schemas here. And so we're going to start our work, our discussions on dimensions and facts and creating the cubes from next session. So for that, let me set some base here. Okay, you know master table. This is, let's say this is your master table and this is your transaction table. This master table, we're calling it as dimension table here, right? And this one we're calling it as fact table. This is dimension, this is fact, this is transaction, this is master. Here dimension table will have columns. We call it as attributes. Dimension tables or columns are called as attributes. Here fact table columns are called as measures. Okay, using these measures you can create calculated measures. Using these attributes you can create hierarchies. So we're going to discuss about all these things just to set some base for you for the coming discussions. I'm explaining you this. Master table, we're calling it as dimension table, and the columns in that one is called as attributes, and the attributes, using attributes I can create hierarchies. So transaction table, we're calling it as fact table or measure group table. You can call with any name. The columns in that fact table or measure group table are called as either facts or measures. Any name is fine. And using these measures I can create calculated measures. This is how it flows. So from next session what we are going to look at is, first session we'll start with what is dimension, how to create dimension, and how to create attributes, and how to create hierarchies. Next session what we are going to do here is how to create fact or measure group tables, how to create measures, and how to create calculated measures, and so on. Okay, so from next session onwards it will be development side. It will be very interesting. So for that, the base, the most important and critical thing is identifying the dimensions and the facts. So try to practice as much as you can before you attend the next session. Okay, so that's it for today. Thank you very much.